Welcome back, Calc students. Today we'll be looking at another related rates problems. I know it's so annoying, but it's fine. All right, this one is about a conical tank. I don't know what it is with math teachers and conical tanks, but that's how it's structured. So let's just roll with that. All right, so let's read the problem. Water is being poured into a conical tank with a height of 12 feet and a base radius of 6 feet at a rate of 10 feet cubed per minute. How fast is the water level rising when the water is 4 feet deep? Okay, a lot of numbers. Okay, let's see how we can set this up. Let's sort of visualize this because that's the first step. So we have a conical tank. Okay, perchance. See this? So it's 12 feet. This is 12 feet. And this radius right here is 6 feet. Okay. Now we're given, what else are we given? We're given that dVdt, because it says it's being poured at a rate of 10 feet cubed per minute. So that's volume. Cubed is referring to the volume. So dV dt is equal to 10 feet cubed per minute. Okay. How fast? Now, what are we trying to find? It says that how fast is the water level rising when the water is 4 feet deep? We're trying to find how fast the height, sort of the height. The height is referring to the water level and how fast that's rising. So we're trying to find, essentially, we're trying to find dH dt, and we're given that we're trying to find this at when the height is 4 feet. Okay, so one thing to take note of is that the height is 12, right? So h in this case is 12, right? That's the full thing, and we know that the radius is 6. So we can sort of create an expression, right? So the height is equal to 2 times the radius. So now if you take the derivative of this with respect to time, you get dH dt is equal to 2 times dr dt. We'll come back to this, but we need this at the end. You'll see why in a second. So I'm sort of stuck, right? So like, how do you solve this, right? Now let's think about this real quick, right? So we're given that we're given volume, stuff about volume. So that means we need to put in stuff about volume. So we have the expression volume of cone is 1/3 pi r squared h. Now we know that h already is equal to 2r. So we can just substitute that in. So volume is equal to 1/3 pi r squared times 2r. Now this is equal to, so you distribute, so like terms, so r squared times r would just be r cubed. So it'd be 2/3 pi r cubed. Now if we took the derivative of this, you get dv dt is equal to, so bring product rule, power rule, so you bring this down. So it'd be 2, sorry about that, it'd be 2 pi r squared. Now we have 2/3 pi r squared. Sorry, 2 pi, this is right, sorry about that. Now we are given that dV dt is 10. So we just plug in 10 right here. So 10 equals 2 pi r squared times, and now the one thing I forgot actually, do you know what error I made? I actually forgot, since we're taking it respective time, you have to multiply by dr dt. That's a very important step that I often miss, and that you probably often also miss. So times dr dt here as well. And what is dr dt? Well, are we given dr dt? No. But what do we know instead? We know that the radius, and the height and the radius are related, right? So if we're trying to find when it's water level is 4 feet deep, then we know that when h is equal to 4, r is automatically equal to 2, because the height is always twice the radius, because it's proportional. So we substitute the 2 in here. So we get 10 is equal to 2 pi 2 squared, which is 4, times dr dt. Now if we just isolate dr dt, we get that dr dt is equal to 5/4 pi. Okay, now, going back to this one. I said you would come back to this. Now, you can just substitute this in. Pretty simple. So you just get dh dt is equal to 2 times dr dt, which is 5 over 4 pi. And that just simplifies to, so it crosses out 2, so 2 is a common factor, so it'd be 5 over 2 pi is the answer. But 5 over 2 pi what? It's not just 5 over 2 pi. We need our units. The units for this is how fast is the water level rising. So it's dh dt. So what is dh dt? It's feet per minute. That's how fast it's rising. Feet per minute. And there you go. That's it. Pretty simple, but a little bit tough, but it's pretty easy once you get the hang of it. And yeah, that's it. Hope you guys liked it. And yeah, that's it. Subscribe and have a great day.